Hello, welcome back to Mr. Kendrick's online math class. This is going to be lesson 5.6 and we're going to be working on scale drawings. If you have the note insert, you're going to fill in the blanks on your notes and then glue or tape the insert into your math notebook. If not, you will just continue on in your notes. You can turn to the next blank page and put this lesson title at the top. Alright, so first we're going to go through some vocabulary and filling in the notes, and then we're going to go through some different examples. Alright, starting off here, we're going to define scale drawing. A scale drawing is a proportional two-dimensional drawing of an object, and some examples of a scale drawing might be a map, a blueprint for some sort of building, or you might see the drawing of a cell in a textbook. For scale model is a proportional three-dimensional model of an object, and some examples of scale models: toy car, model airplane, or model car. Just a smaller example of the real object. Alright, make sure you fill in the blanks on your notes before you continue on. Scale drawing is a drawing. It's a proportional drawing, and scale model is a actual three-dimensional object. Alright, scale. Scale is a ratio that compares the measurement of a drawing or model with the measurements of the actual object. And some examples are 1 inch to 5 feet. And then you can see here, the first one is the drawing, 1 inch, and the actual is 5 feet. And you'll notice there that the drawing is put first, and that's going to be how we see ratios when we're working with scale drawings or scale models. And then that's also how we're going to set them up when we solve for an unknown. Alright, scale factor. The scale factor is a scale that is written without the units because the units are the same. With scale factor, whatever units are given in the problem, your solution must be in those units. But you might have to convert your final answer to specified units. So a scale factor is a scale that is written without units because the units are the same, but at the end you may have to convert your final answer to specified units. Alright, some suggestions for you when you are solving problems related to scale drawings or scale factor. We want to set up proportions to solve, and as always we want to label our units, and when we're setting up our proportion we want to put the drawing the drawing measurement over the actual measurement. Okay, so and same with the scale model. Scale drawing on top and the actual distance on the bottom. Scale model on top and the actual size on the bottom. Make sure you have the blanks filled in before you move on to the next slide. Alright, and this is it for the new notes, and now we're just going to look at a few different example problems, starting with this one. It says the scale on a map is 1 centimeter to 50 miles. The distance between two cities is 3.5 centimeters on a map. What is the actual distance? Alright, so first things, I got a couple notes over here on the side. We want to first set up a proportion, and we want to label our units. And again, we want the drawing over the actual. Okay, so our scale, we have 1 centimeter. So 1 centimeter over 50 miles. And the distance between two cities is 3.5 centimeters. So we got to have our equal sign, and then centimeters is on top, so 3.5 centimeters on top. And our unknown, the actual distance, is our x. So we can put our x here. Now we have a proportion set, and we can solve. So 1 centimeter times x will just be x. So x equals, and then the other side of the equation is going to be the actual distance. So we're going to do 50 miles. So we did 1 times x. Now we're going to do 50 miles times 3.5. So we got 50 miles. So 50 times 3.5. And that is equal to 175. So we got 175. So the actual distance between the two cities is 175 miles. Alright, let's move to the next example here. It says the liquid outer core of Earth is 2,300 kilometers thick. How thick is the liquid outer core of the model? And the scale that we are working with is 1 inch to 500 kilometers. So we have the drawing over the actual. So we're going to have 1 inch over 500 kilometers. And we're going to set that equal to, we know that the outer core is 2,300 kilometers thick, so that's going to be on the bottom, 2,300 km. And we want to know how thick the outer core is on the model, so that's going to be our x. So x is going to go here, and then now we can cross multiply. We'll start with the 500 kilometers times x. So on one side of our equation, we're going to have 500x equals 1 inch times 2,300 kilometers. So we're going to have 1 times 2,300. So we'll have 2,300 over here. And then now we need to isolate our variable of x, and we're going to do that by dividing by 500. And this will cancel out. We'll be left with x over here. Divide 2,300 by 500. So 2,300 divided by 500. That is equal to 4.6. So x equals 4.6. And what does that number mean? It means that the liquid outer core of the model is going to be 4.6 inches thick. Alright, next one here. We have a little map here, and it says, what is the actual distance between Cadillac and Detroit? So the first thing I want us to recognize is our scale right here. That says 1 centimeter is equal to 50 miles. So just to start, we're going to start setting up our proportion. We're going to have 1 centimeter equals 50 miles. So when we set up our proportion, we're going to have 1 centimeter over the actual 50 miles. And we're going to set that equal to another ratio. And now we're going to do a measurement here with our ruler. So first we need to see where Cadillac is. So we got Cadillac right here and Detroit over here. So now we're going to measure that. Alright, so I'm going to put 1, we'll go 0 right here at Cadillac, and Detroit. So Cadillac to Detroit, we got 1 centimeter, 2 centimeters, 3 centimeters, about 3.5 centimeters. So we got 3.5 centimeters between Cadillac and Detroit in our model, and we are trying to figure out the actual distance. So actual distance is going to be our x. That's on the bottom here. Alright, now we have our proportion and we can multiply. We get 1 times x is going to be x equals 50 times 3.5. So 50 times 3.5, that is equal to 175. 175 miles is the distance between, or the rough distance between Cadillac and Detroit. Alright, the next one, we're using the scale factor of 1 to 5 to find the actual measure. Okay, so it gives us a scale factor of 1 to 5, and we're going to put that into a proportion. So the 1 is coming first, it's going to be on top. 1 to 5, and we're going to set that equal to our model's size. So we're going to start with 6 inches in the top, and we're looking to find the actual size in feet, so that's going to be our x. Now we have a proportion, and we can multiply. So we'll multiply straight across. 1 times x will be x equals, and then 6 times 5 will be 30 inches. So x is equal to 30 inches, but now we want to put that into feet. So how many feet does 30 inches equal? Well, we know that there are 12 inches in 1 foot, so we're going to divide 30 by 12 to put it into feet. And so we got 30 divided by 12, and that's going to be equal to 2.5. So 30 inches is equal to 2.5 feet. So the actual size of the model is 2.5 feet. So this is a situation where you can use the scale factor, and it doesn't give you units, but then at the end we needed to convert our inches into feet. Alright, let's look at another one here. Same situation, using the scale factor, find the actual measure. So this time we don't have the model size, but we have the actual size, which is 20 yards. Again, we're going to set up a proportion that looks similar. We got 1 to 5. We're going to set that equal to, we don't know the model. We're looking to find the actual measure of the model, so that's going to be our x up here, and the actual size is 20 yards. Alright, so now we have our proportion, and we can solve by cross multiplying. 5 times x will be 5x equals 1 times 20 will be 20. And now we can solve, dividing by 5 here to get our x by itself. If we do it to one side, we got to do it to the other. This will cancel out, leaving x equals 20 divided by 5 is 4. So this is equal to 4 yards. So x equals 4 yards, but we want it into feet. Alright, so how many feet are there in a yard? There are 3 feet per yard, so we can go ahead and divide our 4 yards by 3 feet. Excuse me, made a mistake. We don't want to, this time we're going from yards to feet, and there's 3 feet per yard. So we're actually going to go the other way. We're going to multiply the yards by 3 feet times 3 because there's 3 feet per yard. So we're actually going to be 4 times 3 will be there 12 feet. So the model is 12 feet. Alright, one more example here. To determine the scale factor, use given scale, convert to the same units, and then write the scale factor without the units. So our example here says identify the scale factor. The scale is 1 inch and 3 feet. Alright, so the first thing is we have our given scale 1 inch to 3 feet, and we need to convert to the same units. Okay, so the first thing we're going to do is 1 inch over 3 feet. And then we want to turn them into inches. So that the top one, 1 inch, is going to stay as 1 inch because we're moving to both being in inches. And this one, 3 feet, we're going to convert to inches. And we know that there are 12 inches per foot. So we're going to multiply 3 times 12 inches. So 3 times 12 will be 36 inches. Okay, so now we've put them into the same units, 1 inch to 36 inches. So now our scale factor, we want to write the scale without the units because they're in the same units. So our scale factor is actually going to be 1 to 36 because now they're in the same units, and we can see that the scale factor is 1 to 36.